So title of this talk is Technical Dimensions of Feedback in Live Programming Systems. And if you saw my essay submission or heard that intro, you'll know that I'm narrowing my focus a little bit for this talk. In the essay, I started to explore this question of what liveness means in general. And it turns out it means a lot of things to a lot of people. I talked about some of those in my essay, which I'll make sure is public somewhere. But in this talk, I want to focus on one particular angle that I've always been really partial to, and that's feedback. According to at least some people, live programming environments provide programmers with continuous feedback about a program's dynamic behavior as it is being edited. And in case you're wondering, according to who, well, here's at least some people. Here's an assortment of papers that use that definition. So there's nothing authoritative or conclusive about this, but I do think it's clear that one way or another, we're all pretty interested in feedback. So I think we should talk about feedback. And I want to make clear that feedback, it's not just one thing. It's not like, does your system have feedback or doesn't your system have feedback? Really, we're exploring a big multidimensional space of programming systems that provide feedback in different ways. So I want to talk about some of those dimensions in that multidimensional space because I think they give us meaningful ways to compare different approaches. So I'm inspired here by the paper on technical dimensions of programming systems that came out last year, which Jonathan, among other folk, were on. It catalogs 23 different dimensions that programming systems can vary along. So each dimension gives you a different question you can ask about a programming system. I think this is great. I think you should check it out. But what I'm going to do today is narrow our focus from programming systems at large to the specific topic of feedback in live programming systems. So I have 5 dimensions to talk about today to get the conversation started, but I'm sure I'm missing really important things. So I hope we can keep talking about this today and beyond. So let's jump in and look at the first dimension, which I call granularity of feedback. I'm going to show 3 systems that vary along this axis. First of all, a demo from Brett Victor. So here, he's editing the code on the right-hand side, and the output on the left instantly updates. That's great, that's live. But there's all these variables and functions and if-thens and all that stuff in the code. So what are they all doing? The system isn't actually giving us any visibility into that. That's kind of interesting. Now here's an observable notebook. In a computational notebook, you break your code up into cells, and the system shows live output for each cell. That's really neat. We're not just seeing a single final output anymore. We have feedback on intermediate values along the way. But there are limits. We still have some if-thens and loops and conditionals and stuff in the code, and the notebook doesn't provide any feedback on what's happening in the code. So we might want live feedback that is threaded all throughout our code. And that's what a lot of interesting systems, including Soren Lerner's projection boxes, does. So compared to these 2 systems on the left, this has a finer grain of feedback. So we're going to make this definition, that granularity feedback is how deeply into the structure of a program feedback is provided. And we can pretty clearly rank these systems from low or coarse grain to high or fine grain. And now it's time to introduce a little visual language that I have for thinking about this. The metaphor is that the programs are kind of lurking underground beneath the grass, and we can't really see what they're doing by default. But in a live programming environment, the program can sprout out little flowers, which are the visible feedback. And importantly, programs are usually made by putting together different parts, whether that's lines of code or functions or cells. So on the left, we only are getting feedback about the final output, but on the right, these different parts of the program are giving us individual bits of feedback. Does that make sense? Everybody likes the flowers? Okay, great. Cool. That's good, because there's going to be a lot more funny flowers. But the last note before I move on from granularity, I'm going to make things a little bit more complicated. I've actually left out an aspect of Brett Victor's system that I showed there, which is that even though it only shows the final output as a single pane, it actually gives you this magnifying glass interaction where you can hover over part of the output and it shows you what code made it and vice versa. So in this way, this is actually giving you a kind of a granular feedback that in some ways is better than notebook style cell by cell feedback because you're seeing everything in context. You're seeing it where it fits together. But which is better? Having separate outputs, having it all in one pane? I don't know. There's a lot to think about with granularity of feedback, but we got to move on. 2, the second dimension, which is reactivity of feedback. Here, I'm showing a simple little program in Notto, which is a very cool Canvas-based notebook. And the pane on the right is sorting an array of strings on the left. And now we want to reverse that array for whatever reasons. So we start typing a dot. And Notto is so live that we get instant feedback. And it's a syntax error because we just have a dot there. So we keep typing, and after a few more characters, we get new feedback, which is that .toRev is undefined. Okay, and then we finish typing, and we get the result we were looking for with a toReverse call. So Notto is reacting to the changes very quickly. It's doing it on every keystroke. And this isn't how a lot of live editors work. For example, in Observable, you need to shift return to run a cell. Is Notto's approach good or bad? Well, it makes things really direct and really immediate, but maybe sometimes it's a little bit nonsensical or a little distracting. Like I know .rev is undefined. That's okay. I'm still typing. So I don't know which approach is best, but one thing I do know is that this is a dimension, and I'm calling it reactivity of feedback. So it tells you how often changes to a program are responded to with feedback. And Notto actually is kind of aware of this dimension. It has a setting over here where if you click it, it turns off the auto mode, and now the cell only runs when you deliberately press the play button over there. So this actually makes Notto less reactive in this sense than Observable. Observable always updates when you move away from a cell. So here's a ranking of these 3 different interfaces by reactivity. And now the x-axis is kind of like a timeline, and these are different states of a program, which are connected by edit actions with these little hands. So on the left, you can have several edits without feedback visible, but on the right, every edit gives you feedback. So there's a lot more to say, naturally, about reactivity, but we have to move on again to the third dimension, which is also about time and change. This one I call velocity of feedback. So far I've been drawing the program editing cycle kind of like this. You see some output, and then you make a change to the program in response. But sad but true fact of life is that feedback isn't always instantaneous. Sometimes there's like a bit of a delay from when a program is in place to when you can see what it does. And sometimes there's a lot of delay. So that one, it's pretty simple. That's velocity of feedback. How quickly is feedback available after a change? We're pretty spoiled today in modern computing that a lot of the things that we do are so fast we can basically pretend they're instantaneous. But if you go back in time, latency of feedback was a big deal. You used to have to type your program on a punch cards, drop them in a queue, and then maybe the next day you get your output. Time-sharing systems drop this latency to maybe seconds. That's amazing. That's a lot more live. But even today, velocity is often on our minds as we build live systems. Sometimes it means we need to be careful in how we implement systems. For example, a lot of live systems are designed to run incrementally, so that when you make a small change to one part, the program doesn't have to run from scratch. It just runs the right parts. And making things incremental, it's hard work, and it's all work that's being done to maintain this high velocity of feedback. And there's still, even after all that, sometimes things just take a long time to run. Like if you're making a data analysis system for scientists, sometimes there are going to be steps that take seconds or days to run, and this introduces design challenges for systems around that. Like how do you design environments where feedback can get out of sync with a program? So tricky questions that we should consider, but we should also move on to the fourth dimension, which is bidirectionality. This one is huge, very big topic. I'm going to cover it in one slide. So on the left here is Sketch and Sketch. It looks at first like your typical split screen code preview kind of editor, but there's a twist, which is that you can directly edit the thing on the right, and that changes the program on the left. So feedback becomes not just something to look at to understand the program, but it becomes a handle for editing the underlying program directly. In the center is the extractor tool from Ngraft, and this one lets you create a program that extracts information from a complex JSON structure just by clicking on the parts that you want. So here, feedback from a previous step in a pipeline becomes a handle for defining the next step. So there's a ton more examples like this. Sometimes they go by names like output-directed programming or programming by demonstration, that kind of thing. But they all share this characteristic that feedback sprouting up from the program becomes a handle that you can act directly on to change the underlying program. As I said, enormous space, very exciting to think about, but we can't do that now. Because we gotta talk about our last dimension, and I think I've saved a really interesting one for last. The name here is definitely to be determined, but I'm calling it criticality for now. And it's demonstrated, I think, really well by this circuit simulation that Alex Worth, who's here with us, made with eToys. The way this is programmed, each circuit component, like the wire or the inverter, it looks at its input dot to see what color is underneath it. Is yellow underneath it or black? And then it uses that color to determine its behavior and what color it becomes. So that means that the thing that we humans are seeing that makes the program's behavior visible is also the thing that's driving the program's behavior. If we turned off the yellow-black thing, because, oh, it's just a visualization, the program would stop running, it would stop working, which means that visualization is on the critical path, which is why I call this like criticality. So here's how I draw this with flowers. You gotta draw it with flowers. So on the left, with something like projection boxes or many other systems, feedback is not critical. It's sort of, in this case, tacked onto Python as a side effect, and we could just as well turn it off. But on the right, with eToys, feedback is on the critical path. In a sense, computation goes through the realm of feedback, the realm that's visible to us as humans. And this is a radical approach. It goes against a lot of traditional computer science principles, like that you shouldn't like mix up your views and your models, and computation should be driven by like elegant mathematical abstractions, not by like dinky little pictures on a screen. But having critical feedback profoundly affects the experience of using a system. The program is looking at and working with the same things that you are as a human. So you're not a second-class citizen anymore. And I think this concept of criticality is expressed really well by Boxer, which was mentioned earlier, and which I hope some of you know. Boxer is explicitly based on this principle that its creators call naive realism. They say that this means that users should be able to pretend that what they see on the screen is their computational world in its entirety. So I think this naive realism is sort of criticality taken to its full limit, where the entire computational world is pulled up above ground. Okay, so those are the 5 dimensions of feedback that I have to offer today, with a 6th at the bottom as sort of a teaser. And as I mentioned before, it's all just sort of a first draft, my first run through of trying to think about this. If you have critiques of some of these framings or like other dimensions in mind, I'd really love to hear about them. So thanks so much. Yeah, and also we can also do it. We can continue to have, if people have questions, I think, about the keynote as well. If you'd like to come up, that's also great. So yeah.
Hi, is this on? Yeah. Thanks. Hello.
Hi. Thank you.
Thanks so much. That was really, really great. I really liked how like this opens up a lot of broadness in what feedback can mean. You're not putting forward this vision that's like this is the way to do feedback. It's more like these are some dials to play around with for different use cases, and I really, really appreciate that. I also really benefit from these visuals, cool. And I'm curious to hear more about like the process of landing on these visuals. Like, was it like your first attempt, or were there like some other attempts along the way? Yeah, thanks.
Yeah, thanks for the question. Yeah, it's a good question. Definitely not the first attempts. I think it is kind of a struggle. There's a lot of like constraints you're working with when you try to make a diagram for something. There's a lot of like dimensions that you're working with, and you're trying to compress it all into something like this. I think I just by chance came up with things in time for the talk that felt like good enough to share. But I think fairly early I felt that I wanted to have visuals, and I'm not exactly sure why. I think maybe it's just that when you're presenting a bunch of things like this, it has the risk of just being kind of a hodgepodge and a grab bag. And my hope was that having a visual language would give some underlying structure that would allow you to like connect together these different dimensions and think about even maybe their interactions. But yeah, I just messed around with it until it kind of worked. I don't know if I have anything better to say. Okay. Oh, and I guess I should call on people. Yes.
I have a dimension I maybe propose, which is deployment outside of your computer. At least that's one that I struggle with. It's like it works on my laptop, but it needs to work not on my laptop.
And in terms of feedback, this is about like being able to get.
Well, because it's like, how do I take that flower and put it in a pot somewhere else?
Okay, yeah. I mean, I don't think this is exactly what you're saying, but I mean, one question is about, now that, for example, we live in a networked world, I may be doing things that are supposed to have effects, sort of places that are far from my computer, like maybe I'm sending out some requests or something is running far away, and how do I get that feedback back to where I am? I don't know if that's quite what you were saying, but
Also,
that one resonates for me.
It just when I work with these systems, it's like it's very nice on my own system.
Yeah.
It's like, but it's not working yet.
Oh, yeah. Yeah. That almost gets into this issue of like, a natural issue with a very big general problem with liveness is, you're seeing the results from some execution, but how much do you know about the generality of that execution? I think maybe this is a way of abstracting what you're saying. So, for instance, even I'm seeing the results with one set of inputs. What if the inputs were different? And this is, of course, why the static typing people feel great about what they're doing, because it's like, well, we have mathematically proven that this behaves a certain way in all possible situations, and we're taking a certain trade-off when we move to like looking at concrete execution. But there's a question of how do you sort of get a sense of the adjacent possible, like somebody else's machine. Yeah, that's great. Okay, sorry, me babbling. Yes, in the second row. Yes. Yes, you. Yeah.
Thank you so much for the amazing talk.
Oh, thank you.
I really liked it, and it really got my thoughts flowing about this type of stuff. So one question I have is how you think about like the representation of feedback, kind of relating to these technical dimensions. Do you think that like the representation of feedback could be like a separate dimension from the ones that you presented? I think it might also relate to moldability.
Yeah.
Maybe I'm guessing like how those representations can be modified by the user. But do you think that like the representation of the feedback is a separate dimension, or do you think there's maybe even some like smaller dimensions within how feedback can be represented to people? Because programs can be represented in many different ways.
Yeah, I think that's a great question. Programs can be represented in many ways, and the things that, like the data flowing through the programs, can be represented in many different ways, and those questions intertangle. So yeah, I think it's got to be like a lot of dimensions about that. In this, I'm sort of thinking here, it's a flower. When I talk about feedback, it's like I'm not even really looking into what's in the feedback. So there need to be more dimensions about how the different flowers can look, and I have so the moldability is related. In this case, what I'm sort of talking about is this idea that when you're working with different kinds of data, for instance, you don't just want to see some generic representation of the data, like, oh, it's just like a JSON dump or something. You actually want to see like powerful, visual, diagrammatic, whatever representations of the system you're working with, and that's something that might not be something that it's not like the system is going to know every situation you run into. It's going to, you're always going to be running into new situations. So here I'm terming that like moldability, the ability to, as somebody who's engaging in the act of programming, mold these representations into new forms. And I'm sort of taking that term from the glamorous toolkit folk who talk about multiple development, and then the clerk folk who have sort of followed in that lineage of moldable viewers. And the representation is it's a weird, different, pretty flower. So yeah, thank you for the question. Okay, I'm going to go to this side a little bit. Michael.
So your visualizations, you can think of as programs in a visual language, or otherwise known as a core calculus, right? So you develop the core calculus dimensions. I wonder if there are other dimensions that core calculus suggests that we can explore also.
So yeah, you're saying that sort of discovering new dimensions through playing with the visual language. Yeah. That's a delightful thought. Yeah, I'd love to do that. I'd love to mess around with a whiteboard or something. Too bad we don't have a whiteboard in here, but maybe somebody knows where we can find one. Thank you for the point. Okay, in the back against the wall there. Oh, okay. Let's talk.
I'm curious if you've thought about, so like there's granularity, which is talking about, it kind of tells how deeply into the structure of the program, but if you think about like projection boxes, right, you're seeing each line of code, you're seeing like each expression, whatever. I'm curious if you've thought about like maybe depth, maybe I would call it, of feedback. So like you could see you can see all of the data, cool, but how do I know like the VM underneath the hood? How is it running? Am I able to get feedback into at the level of the system, and how is the heap going, et cetera? You know, so we can kind of see like a surface level, but we might not be able to see underneath what's going on.
Yeah. Do I have that in here? Oh, that goes into the genuine garbage files. I'm not going to go into that part. Okay. Well, I'll just mention that I was really charmed by a tweet recently of somebody tweeted that their vacuum cleaner showed them the size of the quantities of different particles, and then Andrew, who's I think here, retweeted it with the text, "None of my business," which I think is like a kind of a lesson about like. It's not like turning the dial of granularity up to max is always a good idea. But yeah, you're making a good point that there's sort of like layers of abstraction, say, where when you're working in a programming language, there are things that are kind of part of the semantics of the language that are exposed to you. But for example, how is it laying these things out in memory? How is it like, what is it JITting or not JITting? Yeah, I think that's a really good point in that I see that there's like a bit of a different flavor in that from the granularity as I've discussed it here. And that is stuff that sometimes you want to see. You want to know, like, this is going really slowly. Why? Oh, maybe it's because of like branch prediction on the CPU or something. So yeah, absolutely. Yeah, against the wall, yeah.
Hi, this is a really cool talk. Kind of thinking about trade-offs like in the last question. So like, in like reactivity, sometimes like if you have like a system being very reactive, it's almost overwhelming. But I was wondering for like criticality, what do you like foresee as like potential trade-offs there? Because I feel like the feeling of being a second-class user like is very visceral.
Yeah, I definitely sort of put in I let some of my bias show when I was talking about that dimension, because I'm very like interested in pushing on this criticality dimension, and I think part of the reason why I wanted to speak with that bias is because it is so unconventional, and like again, sort of I think most computer science people would tell you lots of problems with that kind of criticality. Like you're sort of giving up these worlds of like predictable, structured abstraction, things that don't live on a screen, but things that live inside of like data structures that perfectly semantically represent what they're supposed to represent. So I don't know if I can speak too much in detail about the trade-offs, but it's very clear to me that like an awful lot of people are definitely not into this criticality direction. Yeah, that's helpful. Jonathan, you should go ahead.
I love this.
Thanks.
I want to suggest that criticality, which is the coolest like thing going on here, I think. Like this is like sort of the research frontier. The picture there, what you really should have is that above and below are the same, right? That the flower is also below. And this is something
Yeah.
I've called alignment between the semantics of the UI and the programming language. Right? They're the same thing. Maybe one's a subset of the other.
I wanted to call it unification.
Yeah, unification.
Yeah, and you're saying, I guess your suggestion about the visual language specifically is.
Is the flower should be underneath.
Oh, okay. Well, yeah. I mean, I guess the heuristic that I've been using for the visual language is that the line of grass separates things you can see from things you can't see. So I guess I feel like the flower is usually the thing you can see. But
The program above the grass.
what's that?
The program is above
Oh yeah. So in this case, this part of the program is above the grass. This is a system where some parts are critical and some parts aren't critical. But the indication was supposed to be that the program is above the grass. So, but yeah, I mean, I'd be happy to iterate on the visual language a bunch.
You've got to work on the name.
Yeah, I'd love suggestions on that. Next question. Yes, Sakath.
Hi, thank you for the talk.
Thank you.
Yeah, so I kind of wanted to follow up with what you were saying about abstraction and levels of abstraction. It seems like, when you're designing a system, you have to make a decision about like where you want people to stay generally, but I'm curious about your thoughts around like, sometimes you do have to move between them, and like, I mean, I'm sure you've thought about this a lot within Graph. Like, how do you deal with just having to switch between levels of abstraction and keeping options open? Do you need to?
Yeah, I mean, it's a great question. In general, in thinking about this talk, I've been very much like, I don't need to actually solve any problems. I just need to articulate them. But I think in the world of user interfaces, we have a lot of patterns that we use for things like that. Even things, I mean, it can be really prosaic. It can be things like the image of like expanding and collapsing. We're all used to like we're all used to interfaces that show you overviews and let you dig in more deeply. So I think a lot of those like very prosaic interface elements deployed correctly in the context of a programming environment could do the trick. It may not be something super fancy, but I'd also be happy to hear people do have super fancy ideas. And then another example, just like another concrete example, which came up in a recent project I was working on was, so I'm sure there's like a good fancy HCI term for it, but something where focus, like an expanded view, follows around where you are. Something where, if you have a cursor in a code editor or something like that, then the system has some idea of where your focus is. You can use more screen space to have an expanded view of what's happening there, and in other places you can just have summaries for peripheral vision, that kind
Like
of
a
thing.
lens.
A lens, a fisheye, exactly. Fisheye, lens, these are exactly the terms. Thank you. How about in the back? There.
Yeah, I really like these dimensions. I was wondering about, you mentioned how turning the feedback dial up to max is not always helpful. So is there some dimension here about sort of the specificity or economy or informativity of the feedback? For example, I was thinking like if I get feedback about what a variable x's value is, I don't need to also see what x plus 1's value is if that's on the next line, because I can kind of do that.
Yeah, no, that's a great point. I might naively at least kind of fit that into this kind of granularity thing of you're basically saying there are certain parts of the execution that you don't have to show. The most obvious version of that is, levels of structure in, the AST or whatever, like a notebook shows you cell by cell output, but not more detailed things. But part of what you're indicating, I think, is that the structure of the computation itself might give you cues about where it is and isn't useful to show certain things, like as you say, like don't show x and x plus 1. That's a really great thought. I appreciate that. Maybe in the back here, let's do Ivan.
Great stuff, Josh.
Thanks.
I just want to, this is going to be super quick. I want to point out that all of these are talking about feedback that somebody gets from the program, and they suggest the other direction, that there's ways of inputting information into the program that all of these dimensions allow you to play along. And so I think that would be a really interesting...
Like just flipping them.
Yeah, exactly.
Yes, that's a great point. There's something that, I don't know, somebody I showed this to made the point that, well, these arrows that represent edits, they're all underground, which is weird because that's the part that you don't see. And I'm like, well, but it's that you don't see the dynamic behavior, but you see the static behavior, but there's sort of a whole other set of questions about the line of how you actually engage with the program. And that gets a little bit into, I'll put in a plug for sort of trying to socialize the terms like liveness and richness as distinct qualities, and so I have like a paper on that. And richness talks about one particular dimension of how you interact with a program, specifically being able to like interact with it with direct manipulation and that kind of thing. So that would be a part, I think, of what you're talking about. So thanks for that point. Lisa.
Thanks, Josh. This is really great work and really great essay. I have a question about how you think customizability have a place among this dimension. I brought this up because we've done some recent work. Actually, an earlier version was presented at Live last year, so a little bit of throwback. In the recent work we did, we found that users, especially programmers, they want to see different levels of, for example, granularity and then other aspects of dimensions you mentioned, like in the feedback when they're in different modes of programming, like starting from development, incremental development, to debugging, and eventually to testing. They want to see different kinds of live feedback in different modes. So I was wondering, like, have you thought about turning these different dimensions, or at least a subset of it, into like a customizable set of sliders that the user could play with to, get customized kinds of feedback and so on and so forth. Like, do you think of customizability as a separate aspect in the technical dimensions, or do you think of it more like a meta player that could, coherently connect these pieces together?
It is almost like a meta dimension, because what it's saying is that a given system doesn't necessarily like occupy a single point of one of these spaces, but it might give you different handles different interfaces for actually moving around on this in different ways. And I think we saw like a quick example of that. I passed through quickly with Nado for reactivity, where it does give you some like adjustable reactivity depending on what you're working on and your needs. And I've seen other systems that do that too. So yeah, I think for any one of these systems, you might also want to say, what does it mean for a system? For any one of these dimensions, you might want to ask, what does it mean for a system to give control of this to some degree to a user? Yeah, I don't think I have anything more insightful than that to say, but yeah. Okay, Jeffrey.
Curious, do you have any suggestions for us as a community for how we might use a set of technical dimensions to make progress? So, for example, like the work that Doug and others have worked on, they put a bunch of systems on a website and did the work of assessing them against dimensions. And I've gone through that table and thought about it, so I can imagine a similar effort. Maybe people could start like using the dimensions as part of their evaluation sections when they submit to this workshop. Do you have other ideas or hopes for how this sort of thing can help us as a group?
Yeah. Well, I don't like the idea of people having evaluation sections when they submit to this workshop. But aside from that, it's a great question. So immediate thoughts on the top of my head. One hope I have is just that these will be useful, like words for conversation. Like I've found that it's hard when you're having a conversation about, say, like live systems, and you don't have like well articulated kind of like concepts that you can share with other people. So part of my hope is that it's just useful for conversation. Another hope is that it can be something that's generative, something that where if you're like designing a system, you can sort of run through these and say, well, what is the relationship that this system has with granularity or with bidirectionality or whatnot? And then I guess you're also mentioning the sort of the task of going through existing systems and trying to understand them this way. I think that would be a useful exercise to do. Maybe I'll do that. I don't know. It sounds like some work, but well, maybe we can do it together. I don't know. Let's split it up. Yeah. Thanks.
We have time for maybe like one or two more questions.
Okay. Cool. How about in the back?
Thank you. So have you ever thought about a new dimension, the vividness of the output? For example, a plain text unformatted syntax tree is, of course, less informative than a pretty printed one, and also less informative than, for example, an interactive one.
Yeah.
Yeah, I think in your metaphor, that might be the growth of the flower.
Yeah. And I really appreciate getting the word vividness. That's a very helpful one to work into this. And I think that when I articulated this sort of moldability dimension during some Q&A, I guess in that case I'm sort of focusing on giving the user control of like how do they represent it. But even before you talk about user control, there's just the question of how helpful is this feedback? And because when you talk about a pretty printed program, it's not just that it's like more colorful, it's that it actually hopefully like helps somebody understand it. And we all know like the world of like rich, well-designed visual representations is just so powerful. So articulating the degree to which a system gives people access to those is a great question.
Okay, thank you.
Okay, I'll give Peter a privilege.
I'm gonna oppose one of these dimensions.
Cool.
Isn't velocity necessary? And not really, like, if your live programming system doesn't give fast feedback, it's not live, it's dead. That's the whole point.
Yeah, and there's a funny thing where when I listed all of those like citations here, they actually almost all before the word feedback they say like immediate or continuous or things like that. But I don't know. I'm a little bit informed here by I had a chat with Steve Tanimoto, who arguably coined the term liveness back in the 80s, and he sort of told me this context of like, well, when he was writing that, like the memory of the progression of computing was very vivid in the mind, of going from the punch cards to the time sharing system to the graphical user interface. And I think I feel like each of those steps was a step forward in liveness. I don't know, it's sort of, maybe it's a semantic argument, but there's a sense in which like, immediate, these are all sort of in the eye of the beholder, they're all relative. So yeah, and the yeah, sorry.
It's kind of the only one you have where I can't imagine good reasons to be at either point.
As in it's only a good thing.
Always better to be.
I think that's a fair point. Yeah, I think that's a fair point that it's not one with some sort of like interesting design questions or where you want to be. You just want to be high up. So yeah, you're right. It is different in that way. I appreciate that.
Well, it's annoying when you're typing things and the system is yelling at you.
But that's reactivity. That's a different one. Yeah. This one is like, these are all, I call these technical dimensions, partially as an homage, but also to emphasize that they are all aspects of the system as a technical artifact, as opposed to, you could also, by the way, this is a great point to mention, there's a whole world of like social dimensions that you could mention of liveness, where you could talk about what liveness means in the sense of like people's experience of it and people's experience of it with each other. I'm not doing that here. I would say that this velocity is maybe like too technical. It's like it's very implementation-y, but it's in there. Maybe that's enough.